Hello, we are back. See, the last when I left you, I took you to our fabrication shop and I was trying to explain to you how we work with sheet metal. So, sheet metal has the advantage that in a given thickness it is very rigid and then it can take a lot of, use a word called beating, meaning a tremendous amount of stress and it will not get dented. But you will notice it that fabricating things using a general purpose machine in a fabrication shop is not so elegant, and then in large quantities it leads to a problem. So, you see here that we have a box which is still made using normal bending tools and all that, and then in the end these corners have been resistance welded. Such a conduit box in low quantities it probably makes sense. Then whenever the design changes we end up with problem of how to make these things, and then it's not economical. First of all, it is heavy, and then the chances are because of this conductivity problem, even if you were to put a fascia plate and then mount modular switches, chances are they will short circuit. In the course of our fabrication, slowly things are being replaced by insulated materials, and the moment we talk about insulated materials, we talk about various types of plastics. So, in case it is supposed to be meant for high heat and arcing and all that, they use thermosetting plastics. But in the case of these are all thermoplastics which can be injection molded easily. Here is an actual conduit box which is a direct replacement for this. One of the things you will notice is this has been made for the old circular electrical conduits. You see here, this is a conventional conduit box. It comes with a faceplate, and the faceplate has a provision for 3 modules. That is, either you mount 3 switches or you can put one single switch and a 2 module plate and so on. Well, this seems to make sense when we talk about, whenever we talk about new modern wiring and electrical conduits, the circular hardware is becoming a little unmanageable. And then added to that, you see here what we call knockouts are provided here, so that we punch them out. We either push them with a special tool, or often it is just enough if you give it a gentle tap and it will come off. It has all been replaced now with the new range of these devices. You will see here there is a simple knockout, and these are all been made with the flat cap and case system, and it's somewhat universal to the extent that if you take a 1 inch or a 1 1/4 inch cap thing, it terminates here, and then the wiring can be taken. This directly fits a fascia plate which I was talking to you about, which carries these switches. Alternately, you have general purpose boxes here, which again we have the same mechanism here, and then we have a cover. Now, this can have multiple applications. We can open this here to fit any other hardware we like, or we can also use it to use this modular plate switches on this. That is, we have a fascia plate which sits on top of it and so on. While this is for a general purpose thing, now I come to very interesting things here. You see here we have an equipment which was made once upon a time using sheet metal. The reality is you do have a cover, and then if you remember, I was talking to you about this operation in the fabrication shop. Offsetting something by one thickness is called joggling. So, a joggling tool has been used, and then very how do you say, innovatively, something has been done that if you see only at close range, you can see how the corner has been formed. So, something has to go down here and so on. And finally, if you now look carefully, most likely the whole thing has been formed out of a single sheet. Positive advantage, there is no mechanical damage in the unlikely case of something falls down, but you still have radiuses and so on. Now, this whole thing, when it has comes to commercial application, has been replaced by full molded plastic. This is not a very elegant design. It seems to have been something which made to be a little retro, flat sheets and then little bit of displays and so on. So, as things have progressed, things have now been replaced with this new types of accessories. This one is an accessory which is required for the as a mobile, as an external speaker. You see here again, once again, it does have things which are just part of a normal thing. We have plastic items here, they have something, and this looks like it is just only a protective cover. So, by playing around a little with all these various items, it is possible for us to come with really interesting and novel combinations of materials. Even today, this speaker grill continues to be of metal, anything else has a tendency to rattle. Then insides are made with some thermoplastic, it can be easily molded. This outside is just a soft cover. It has a dual purpose. One of them is that it should not, when it falls, it should not shatter the corners, plus it gives a soft feeling. And then all that things have been, they've been playing around with this such that it gets assembled in one particular way, and then we have things very much in control, absolute full control of our design. Has progressed from mere flat geometry to other geometric primitives. You have something here which probably looks a little like an old speaker. There are small visual cues which makes it look like a round speaker, and then you have something with which you can hang here, hang it from, and then you have obviously various types of controls and so on. This whole thing is easy for us to fabricate. It can be in metal or in plastic, and if you are to make one-off samples, most likely for the prototype purposes, the fabricator will probably choose materials which are easily available. The outside enclosure, this enclosure can be made with a circular PVC round, and then this grill can continue to be a metal grill, and then all this detailing can be done with various other types of plastics. And part of the novelty will be sometimes they are also made with acrylics so that you can see what is inside, and once in a while they will become very, very popular. Only when you start making a prototype, you will notice that small detailing like this saying, where you will make this stowage for the cable, can all be worked out. While at a design stage it is possible to still make them, if you make the first prototype, you can now include all this into the design and see if there is any potential places it will get damaged. I will now take you over to some other items. This is a general purpose box for making small items. So, in this box you will notice that there already it comes with some drilled holes, and then you have to have flanges with mounting holes, and then on the other side it is covered. When I open it, there are enough details which are available here for us to play around with it. Main advantage being that this being made with a modified version of ABS, but the other components have been reduced, and this is probably made with a very low cost polystyrene. So, I am not very familiar with the Whether they have used the technique, generally somewhere, no, they will include what is the type of material for recycling purposes. You will notice, though it is basically a flat object made with flat planes, still be molded and probably suits several type of our prototype applications. Now I will progress on from here to see when somebody you see here, this is a typical sheet metal aluminum enclosure that has been made, and people have tried to duplicate whatever it is in the sheet metal using plastic materials. So you have here a plastic material. This was made in fact as a backup what you call device for a calculator, so that the calculator base is not damaged. While in a small this seems to work. Now we move over to this new concept called rapid prototyping. We have this, from here onwards I will try to show you how, instead of working on this saying cut and stick type of materials, how we can move on to more advanced technology. I will point out where the use of these plastics is a must, even in routine things like automobile. Contrary to intuitive reasoning, you cannot go ahead and say analyze. You can't analyze an auto rickshaw. There is nothing like there are no equations to start a design of an auto rickshaw. So somebody have to conceive an auto rickshaw here, and then if you see, this whole conception has been done in the mind, of course, and then a little bit of I will say sketching, hand sketching, which I covered in the third or fourth lecture, and eventually a prototype from the design point of view has been made. So traditionally all this is, as I said, styrene sheets. There is something with two wheels at the back, then there is something with two wheels in the front, with one wheel at the back, and so on. After coming out with an outside structure, you end up with the actual load bearing structure. This load bearing structure for the first time now reflects what can be analyzed. Without this, no analysis is possible. So we have the external top down approach, we start there, and then we come here, and then of course this is old, as old as some 30 years. I think this we first started in 90, and then I will point you out to the original CAD drawings that have been made here. This CAD drawings will show you that a wider front seat makes sense, and then these are all the electrical things, and then you see here finally this is the fabricated prototype. So I am very happy that some well known people are here, and all my colleagues are here, including me and my other items. Now I will stop here, I will get back to the plastics demonstration. When we replace any of the sheet metal parts, first thing that occurs to us is, let us make it flat, and then the corners and all which normally take on a joint will eventually be replaced with, if you have a piece like this, how do we make it strong? We depend on adherence to the adjoining part. Same here. So in this case, this particular piece has support here, and support at the bottom. Sometimes this is not sufficient for us. So what is done is, a piece like this is used for reinforcing the corners. Sometimes it will be a tapered piece, sometimes otherwise it will be same material, and then you cut it to the correct length after the fabrication, and then try to use engineering adhesives and then make it adhere to this. After that, when you turn it over, right now it is just made as a simple rectangle. Eventually you can reproduce, if the inside is already anchored properly, you can smoothen it out outside. So the same thickness here and same thickness here and the same thickness here will be maintained, and eventually you will have a part which, if this sample part is handed over to the fabricator, the part designer will optimize it such that injection molded tools can be easily made. From here now I will move on to some very interesting concepts. See here, the whole thing has been laid out using a single sheet of acrylic, and then classical dovetail fit has been given. It looks a little like the jigsaw puzzles which as children we enjoyed doing it, except that in this case it has been made such that these pieces are practically identical. So, if you just fold them over and try to make them, you have a beautiful cube. Right now, unless I constrain it using what you call an elastic band, it does not stay there. While as a novelty, it works out well, and it works extremely well when these pieces are actually constrained. My pack of cards has collapsed. If you carefully use an adhesive and join them together, they can hold their shape. But in reality, what happens is, if you are to make some equipment using such a technique, it does not work well, because we end up with losing that structural integrity of the whole part. So, over the years, by a little bit of trial and error and a little bit of following the various things on the available resources, some of our designers have come out with this unusual concept, saying there is no necessity for us to have the external flush joint. It is maybe much more logical if you have one of them going and sitting into the other one like this. So, building on that whole concept, near replacements of metallic objects have been made here. You have seen here the side still looks a little like this joints that have been made, that is, you put things here and then try to fix it. This is actually probably a broken piece. The original piece was intended like this, and then the top and bottom have this, instead of having a dovetail, they have actual places where things sit, and in the end we have a beautiful enclosure which is made out of colored acrylic. This whole thing has been made of black colored acrylic. So, we have a beautiful motor here, and then you will also notice it is not the first time or anything. If you go to the hobby network, seen this is part of a line follower car. So, this line follower car, there are various types of sensors, and we have things here, and then it is supposed to work here. And you see, if you see the base, this base has been cut out of a acrylic sheet. This whole thing is an acrylic sheet. Some corners you can find the material of the acrylic sheet. So, plastic continues to be a very versatile material for making these things. Next level is, how do we go about fabricating things in plastic? It is possible for us to actually release these materials out of actual acrylic using a laser cutting technique. You need not despair if you do not have a laser cutter. All it needs is, you must start with a rectangle and then use all your skills, and maybe you can even remove the material. Only in this case, after I remove this material inside and then if I try to make a thing, I still can make a piece like this. So, this can also be made by hand, but if you want it in a medium large number, like let us say if you want a few hundred pieces, it is very uneconomical either to use an injection molding machine or to start doing it by hand, even if you have a template. In such cases, we move on to the laser cutting machine. So, in the background I have this laser cutting machine which is slowly getting popular. So, we have this laser cutter. So, it is magic. So, in the magic, inside this magic, you will notice that we have the actual device which focuses a laser point here, and then there is a lot of other things which are there. Then you see there is a beautiful rollers here. So, you keep your raw material, the raw material can be slided, it can keep here, and then after that, after the cutting is over, that is you close and start the cutting operation, you have, give me that thing. You can very easily get any of these materials here. You see here, it will start here, it will be datum line, and in the end you can have multiple pieces which are practically identical. And if you can do things directly at the drawing board stage, it is possible for us to reproduce this material. Next round, I will request my colleague engineer who can load this machine and then show you the actual cutting, except that it is a little action oriented. You will not mind, you will not see much about it. Let me start from where I left off with the issue about this laser cutting. We use laser cutting essentially on planar materials, and the machine we have here is only a plastic cutting machine, meaning the peak temperature and the energy involved in the laser can cut the plastic and polycarbonate up to maybe around 6 millimeters, and the dimensions and all you can easily calculate depending on the size of the bed. Though it looks as if it is a very ancient and old technology, it is now stabilized enough for us to use with feature sizes which are down to a few microns. So, even in our new sense, this thing that is nanosciences, we continue to use these things. Today, I will try to show you a job which is being run here. If you now look at the monitor, you will see that we are looking for a job which has a particular profile that has to be removed out of a material, and then we have 4 holes which have to match with this, and then there is a cover also with it. Most important in this point is how to sequence the operations. Imagine in a conventional fabrication shop, what would you do? You will probably cut this and then go about trying to drill holes in it. Such a thing is not possible in this case, because the cut piece will fall off into the machine. So, what is done here is a particular sequence and hierarchy of operations are listed here. So, what is done here is first this profile is taken, and since already this machine is in that same thing because it is in a planar shape, we next open these 4 openings. 2 or 3 things will happen here. One of the first thing that will happen here is nothing outside has gone. It will be still a sheet with the profile cut on it and these 4 holes which are made, and then an empty cover on top of it. Now, once these operations are over, this around 40 mm the 30 mm by 40 mm piece will now be cut off. After this, when you now open this and have a look at it, you will notice that they are perfectly matched, and you have the jobs which just need to be released from the raw material. So, I will now take you to the laser machine. I will just cross over to the other side. We need to stack those objects. There is no other method by which this perfect alignment is done. So, you see here he has placed the job here. About the machine, if you see carefully, anything which is heat producing, the cutting, all that has been shielded from us. So, even if you open the cover and use it, we can continue to use. Unlike high power lasers which are used for sheet metal cutting, here it is safe, and if you are safe with all the gases that emit during the cutting operation, you can once in a while open it and see it. But normally, once we close this is a cover. Once we close this cover, it is not to be touched until the job is open. Now, I will open this and explain to you how the machine works. The actual power laser is mounted at the back. We have a series of lenses and prisms here which direct that. This one is a silvered mirror which direct all that. Then we have a small lens here, and then it points it to a correct operation on top of the sheet. Part of this machine is that it has to be attached to that PC in which the original profile has been drawn out, and then a zeroing has to be done. So, using the inching facility here, we bring the point to an available space where the cutting can be done. So, in this case, this raw material is, specially they have selected the raw material which has the correct refractive index, and then this has already been used, and then this white tape is required for their processing. So, the laser head is now positioned somewhere here so that the cutting operation can be done here. Moment it cuts here, whatever that small dimension of some around 30 mm by 40 mm, you will get the 3 pieces here. Depending on where the material is, you can have it here or here, but generally I expect that they will start these things here. And important thing is, this is a tape which is used for stacking, and main specific advantage of this, under all conditions dimensions are maintained, and usually a test piece is run to make sure about the linearity and the, in case there is a thickness loss during the cutting process. Now after our engineer starts the machine, we will see these things, and these are all meant for other raw materials where the load is taken. And then you see here, this is nothing but a stackable removable bed, and then at the bottom we have a shelf in which all the excess materials will come. If you remember the old first thing sequence I told you, whatever is cut off will fall off inside, we don't need it anymore. So you will have 4 dots and that profile will fall off, and the outside line is cut. Then afterward they remove the sheet, and then you have this, and then they check whether the alignment is correct or not. Once the alignment is correct, our job is done. So we'll wait until the machine starts. I will now get you back onto the good old drawing board. Drawing board has almost become an allegory for design board. If you see several textbooks in this area these days, no, they do not talk about computer aided drafting. Drafting is still little legalized compared to actual design. It is all about computer aided design. So, things like this continue to be made on a flat two-dimensional plane. And in fact, all the CAD programs and all what you come about will all probably start with this. You still have an X, a Y, and then a local datum and things like that. This is right now obsolete because we continue to use more practical digitization techniques. But I could locate the drawing with which that other parts were made. This is the old drawing. You see here, occasionally at the back, our engineers continue to draw things by hand, including title, making all these things and all. Only as a last and final thing, they actually move it onto the computer screen. So, I will stop here and then get that laser machine fired up, and we will see next when it is ready.